A gun is aimed so that it points directly at the center of a target 200 meters away. If the bullet travels at 200 meters per second, how far below the center of the target will the bullet hit? Okay, the goal is calculating delta y, which is the vertical displacement from the center of the target to the point where the bullet hits. Delta y is the area under the graph in vyt. And we know that vertical motion here is an accelerated motion with acceleration of -10. So Vy must be a line with negative slope. Something like this, or something like this, or even something like this. For choosing one of these three lines, pay attention to the beginning. At the beginning, the bullet has been shot exactly to horizontal direction, and so Vy at the beginning will be 0. So Vy will start from the origin, something like this, with the slope of -10. Delta y is the area under the graph here. So for finding this area, I must have t, the time of this travel, and also the v, which is the final vertical velocity. Okay. For having t, let's concentrate on plotting vxt, because we have all information needed here for plotting vxt. Vx is constant. I again remind you that fx is 0. After we shoot the bullet, we don't exert any horizontal force on this, and so we expect no horizontal acceleration. So Vx has been initially 200 meters per second. It remains constant forever. Okay, the area under the graph here is 200 meters, which is given here, the distance between the gun and the target, horizontal distance. And so in this rectangle, width is 200, length is t, so 200 width times length, which is t, is equal to 200 again, and t is 1, so the time of this travel is 1 second. Likewise, we put it for Vy against t. Okay, here I need to find Vy, the final vertical velocity here, to calculate the area under the graph. Okay, pay attention to this triangle. In this triangle, the height is Vy, the base is 1, and the slope of this hypotenuse is 10. So slope is 10. Slope is height over base. Height is Vy and base is 1. By rearranging this equation, I will have Vy to be 10 meters per second, final vertical velocity here. Okay, area under the graph will be delta y here. Okay, base times height over 2. Base is 1, height is 10. If I divide it by 2, I will have 5 meters. So the bullet has been displaced 5 meters vertically from the center of the target to the point where it hits.